In previous session, we discussed few problems on Fourier transform, where we discussed detail problem number 9. Till today's presentation, we are going to discuss further problems on Fourier transform, where we are going to use the application of some properties. But nothing but like we taking some any one of the properties out of Fourier transform, whatever the list of properties, out of that, by using any property, we are going to simplify the given expression either in terms of to find Fourier transform or to find inverse Fourier transform. So we'll take up one particular problem over here, which is statement is like this: find the inverse Fourier transform of the following using appropriate properties. So we have to find the inverse Fourier transform. Nothing but the given is Fourier transform. The signal, that is x of j omega, is given. So for this I have to find x of t using some of the properties, appropriate properties. So x of j omega, whatever the given is, it is j omega divided by 2 plus j omega whole square. The term is given in this order. So let me write that x of j omega plus j omega by 2 plus j omega whole square. So if I look the expression, suppose I just take 1 by 2 plus j omega. If I look that particular term, that x of j omega, nothing but Fourier transform, if it is in terms of 1 by 2 plus j omega, that is nothing but this is the Fourier transform of exponential term x of t. So if suppose I have this is the first problem where I discussed under the Fourier transform, the two sessions earlier, which we discussed about this particular problem and which we solved. So it says e to the power minus at u of t. If I have this term, if I take the Fourier transform of this, I'll get 1 by a plus j omega. So if suppose I use this term with respect to into this equation, so if I take a is equal to 2, then e to the power minus 2t into u of t, if I instead of a I am using 2, the term is now, the Fourier transform of this is now 1 by 2 plus j omega. So the term e to the power minus 2t into u of t, its Fourier transform is 1 by 2 plus j omega. So this term, if I look into this, the given x of j omega, 1 by 2 plus j omega term, with respect to that, comparing, there is a changes is the square in the denominator and also j omega in the numerator. So j omega can I able to get, or the term which we can get by the help of either the differentiation term or properties, we can use it. So this is what the term which I just need to be taken out. So I'll use frequency differentiation property. So the frequency differentiation property, it says minus jt into e to the power at into u of t. If I have that term, if I take the Fourier transform of that term, is d by d omega of 1 by a plus j omega. So this is what the term which is expected. So minus jt with e to the power minus 2t u of t. If I take the Fourier transform of this term, I should get differentiation with respect to the frequency term. For the term is this, that is the same thing of this 1 by 2 plus j omega. So I'll keep the left hand term as like this, but right hand side, the differentiation is required for 1 plus 2 plus j omega, 1 divided by 2 plus j omega. If I differentiate the square of the denominator and in the numerator, differentiation of a numerator is 0 into denominator minus differentiation of denominator is j into numerator is 1, so minus j divided by 2 plus j omega whole square. So this is what we can retain, but either side minus j you can remove it out, not required at all, though this is a term as a constant which we can fill it. So t into e to the power minus 2t into u of t, its Fourier transform I should able to get 1 by 2 plus j omega whole square. Coming to this given term x of j omega, it is j omega is now is not there in the numerator, except the other term is 1 by 2 plus j omega whole square is already there. So to get j omega with respect to the frequency, j omega to get, what we can do for the given for the term x of t, what we can do, time differentiation. So using time differentiation property, so differentiation of this term t into e to the power minus 2t into u of t, its Fourier transform should be j omega divided by 2 plus the x omega, j omega into x omega. X omega is this, its Fourier transform is 1 by 2 plus j omega whole square. So what I require, I got now x of j omega of the term x of t is this. So x of t, therefore d by dt of t into e to the power minus 2t into u of t, this u of t differentiation is u of t itself, but differentiation of t into e to the power minus 2t is 1 minus 2t into e to the power minus 2t. This is directly can take differentiation for this term and I will get simplified answer. X of t is equal to 1 minus 2t into e to the power minus 2t into u of t. So hence we got the inverse Fourier transform of x of j omega to get x of t by the help of properties. So here we used frequency differentiation and also time differentiation property. So appropriate properties have to be used for any given particular condition. So if they specify the particular property have to use, then we should go the corresponding property itself. Moving on to the next problem. Problem number 11, it says find the Fourier transform of the signal x of t shown in a figure. So we have x of t which is shown in this particular diagram, and for this I have to find the Fourier transform with the help of time differentiation property. They specified the time differentiation property here. So whatever the case, to get the Fourier transform of x of t, I should use time differentiation property. So let me define the time differentiation property first. From the time differentiation property we can say if x of t I do Fourier transform, I will get x of j omega, but time differentiation it says d by dt of x of t, its Fourier transform should be j omega into x of j omega. So differentiation of x of t will be j omega into x of j omega. Earlier also we saw in the previous problem. It's the same thing which I have to use now for the given x of t. So x of t first we have to use in terms of equation. That's why we'll take it the given x of t diagram in terms of equation we will write. So x of t which is equal to 2 plus t for the time interval minus 2 to 0, x of t which is equal to 2 minus t for the time interval 0 to 2, else it is 0. So this is what x of t in terms of expression. If I take the differentiation of this x of t, we can do, or we can write it as differentiation of 2 plus t is 1 over the interval. Same thing, differentiation of 2 minus t is equal to minus 1 over the interval 0 to 2. Else it is 0. So differentiation of 0 is 0 itself. So this is what differentiation, one differentiation of x of t. So I can also plot that differentiation d by dt of x of t. So differentiation of this triangular wave, I just get it as a square wave with the amplitude of 1 and minus 1 over this particular interval. So but we will try to do the time differentiation twice. So let me take and I'll discuss about this particular point later, why we need to take double time differentiation need to be applied. So we are applying once again the time differentiation property for the time differentiated properties. So d by dt of x of t, its Fourier transform is j omega into x of j omega. If I take again time differentiation for this, so d by dt of x of t, nothing but double differentiation of x of t, its Fourier transform should be j omega into j omega of x of j omega. So this is acting as a x of j omega. So x of j omega is j omega into x of j omega. J omega is one more term is going to come. So j omega whole square into x of j omega will be the double differentiation of a given x of t. So that is obtained taking time differentiation twice. So same thing x of t whatever we have, so with respect to d by dt we written. So d by dt of x of t is also plotted in the graph also, but if I represent the double differentiation of x of t, the differentiation of this term if I look it, The differentiation of this term means till minus infinity to 0 value is 0. If I do differentiation 0 itself, so at minus 2 to 0 value is constant. The differentiation of constant is always 0, so minus 2 to 0 is 0 itself. But exactly at 2 value is changing from 0 to 1 at that particular instant of time. The value is changing. If I do the differentiation, there should be existence of that changing the value. So what is changing the value? It is 1. Hence at minus 2 we will have the amplitude of 1 and pulse which we are able to get. This is what we call it as an impulse function will be retained at that particular point with an amplitude of 1. Hence you can take it this as delta t with the shifted version of minus 2. So it is the term point, we can represent it as delta t plus 2. If I coming into the point at exactly as 0, so what is happening? The amplitude is changing from 1 to minus 1. So value is shifted. 1 to minus 1 means total 2 value is shifted. So at 0, now if I take the differentiation, so value should be have 2, the pulse or impulse should have an amplitude is equal to 2, but this transition is happening in the negative direction, towards to the negative direction. Hence this impulse at the negative direction of at 0 we have delta t itself, but amplitude is minus 2 with the negative direction, so minus 2 delta t we can take it this impulse function. But in between 0 to 2, if I do the differentiation, value is constant as minus 1. If I take the differentiation should be 0. But exactly at 2, we are having the amplitude changing from minus 1 to 0. If you do the differentiation, it is an impulse function to be generated. But this value is changing from minus 1 to 0. So towards to the positive. Hence at 2, we should have the amplitude in terms of delta t itself with the amplitude equal to 1. But this is a time shifted version at 2, so it is delta t minus 2. So the double differentiation of x of t, now I should be able to have this particular terms will be remained. So if I take the expression for d square by dt square of x of t, then I should have delta t plus 2 minus 2 delta t plus delta t minus 2. This is what we will represent it now. D square by dt square of x of t is equal to delta t plus 2 minus 2 delta t plus delta t minus 2. So taking the Fourier transform of this, so what is going to be happen on the both side using a time differentiation property. The earlier I just mentioned using the time differentiation we can take the Fourier transform of double differentiation of x of t should be j omega whole square into x of j omega. This is what I should have, but for the right hand side we have delta. So if I have delta t, its Fourier transform is always going to be 1. So delta t, its Fourier transform is always going to be 1. If I take delta t plus 2, its Fourier transform should be the delta function will be defined e to the power minus j omega t with the t I have to be defined here with the t is equal to minus 2. Hence j omega t is minus 2, so j minus e to the power minus j omega t, where t is minus 2 means e to the power j 2 omega will be remained. For this term minus 2 into 1. For this term it is a shifted version, hence t equal to 2. So e to the power minus j omega t with the t equal to 2 means it is e to the power minus j 2 omega. So this is the property which I just the differentiation of delta function will be defined as like this. This is 1 here. So that we can get the Fourier transform of right and left hand side in terms of time differentiation property for the left hand side of what we represented here. This is normal differentiation Fourier transform of the delta functions, impulse functions I just taken. So but what I have initially I had is x of t. So for x of t I have to find x of j omega, but in the left hand side we have j omega whole square. So let me take this j omega to the other side. So I'll try to remind in the left hand side as x of j omega what I look forward. the final answer. So e to the power j 2 omega minus 2 plus e to the power minus j 2 omega divided by j omega whole square. So you can take j square means this is minus 1 minus take to the numerator also. So minus 2 becomes plus 2 with the other is both term exponential term is a positive sign. So it will be changed as minus of e to the power j 2 omega plus e to the power minus j 2 omega divided by in the denominator j is square is taken out to the numerator, so only remaining is omega square. So in the numerator we have exponential term together. If I divide by 2 into 2, what we will get cos 2 omega, 2 cos 2 omega, where 2 is common, so taken out is 1 minus cos 2 omega divided by omega square. So this looks like 1 minus cos 2 theta, that is nothing but 1 minus cos 2 theta is nothing but 2 sine square theta. So that is 2 sine square theta, but already I have 2. To 2 into 2 is 4. 4 I can also write 2 square, 2 sine omega whole square divided by omega square. So square I taken outside, what will remaining is x of j omega as 2 sine omega divided by omega whole square. So this is what the final answer. X of t, I just got it for a transform. I got x of j omega. So that is in terms of x of j omega, which we got it to got the final answer as x of j omega in terms of 2 sine omega by omega whole square. So moving on to the next problem, problem number 12. Statement is like this: find the Fourier transform of a signal x of t is equal to e to the power minus 3 with magnitude of t into sine 2t using appropriate properties. We have x of t. For that I have to find the Fourier transform, means I have to find x of j omega. I have to get it final answer by the help of some properties. So here they are not specified any properties, so let me try to solve this with the help of some properties. First of all, I'll take the given equation x of t is e to the power minus 3 with magnitude of t into sine 2t. So sine I'll represent it as in terms of exponential. The sine theta I'll write it as e to the power j theta minus e to the power minus j theta divided by 2j. So here theta is 2t, so e to the power j 2t minus e to the power minus j 2t divided by 2j into the exponential term as it is e to the power minus 3 with magnitude of t. So let me multiply towards to the inside. So 1 by 2j outside I written. So what is going to happen? E to the power j 2t into e to the power minus 3 with magnitude of t minus e to the power minus j 2t into e to the power minus 3 with magnitude of t. So now we have here is e to the power 80 term looking like e to the power 80, e to the power minus 80 with the magnitude of t we have. So we have the second problem which I discussed under this particular module or Fourier transform. So the second problem which is with respect to this e to the power minus a into magnitude of t, its Fourier transform is always going to be 2a divided by a square plus omega square. So here that e to the power minus a with magnitude of t having a 3 here, that means a is 3. So e to the power minus 3 with magnitude of t, its Fourier transform should be 2 into a, that is 2 into 3 is 6 divided by a square, that is a is here 3, 3 square is 9 plus omega square. So if I take the Fourier transform only for this e to the power minus 3 with magnitude of t, I will have 6 by 9 plus omega square. But I have to use the exponential term e to the power j2t with the exponential term. So I can go and look into the frequency shifting properties. Frequency shifting property, it says e to the power j beta t into x of t, its Fourier transform will be x of capital X here, x of j with in a bracket omega minus beta. So j multiplied with omega minus beta. So this very looks a resemblance onto this particular term over here. So e to the power j beta is 2t into x of t is, now I just need to consider this. So this is x of omega. So x of omega need to be x of j omega. So x of j omega need to be changed as j omega minus j beta have to be written. So beta is here, so I just taking this term along with this implementing through the help of a frequency shifting property. So e to the power j2t into e to the power minus 3 with magnitude of t. So beta here it is 2. This is x of t. So I should have x of j omega along with this beta need to be introduced. So 6 by 9 plus omega, instead of omega I should replace by beta. So omega minus beta, sorry, omega replaced by omega minus beta. So omega minus, here it is positive, so omega minus beta is here 2, so omega minus 2 whole square. So for the second particular set of term is e to the power minus j 2t into e to the power minus 3 with magnitude of t. Its Fourier transform should be 6 by 9 plus omega minus of minus plus, so omega plus 2 whole square. So by the help of frequency shifting, so I just got these two terms. So now I'll go back and I'll write x of t. Its Fourier transform should be 1 by 2j constant. However, as it is for the first term, I'll write 6 by 9 plus omega minus 2 whole square minus second term is 6 by 9 plus omega plus 2 whole square. So 6, if you take it outside, 6 by 2 is in the numerator, 3 is remaining, so 3 by j within a bracket I should have 1 by 9 plus omega minus 2 whole square minus 1 by 9 plus omega plus 2 whole square. So this is what the x of j omega for a given x of t term. So for a given x of t, I got x of j omega with this answer. So this is where we used the frequency shifting property. They are not specified any particular property, they specified an appropriate property. So here we used the frequency shifting property for this particular problem. So moving on to the next problem, the problem statement. Now we need to look forward. Find the Fourier transform of the signal using appropriate property. This question asked in the previous your question paper, where you can look forward this particular problem. So they specified only appropriate properties. X of t is given is d by dt of t into e to the power minus 2t into sine t into u of t. So we have sine t, so what we can do is substitute for sine t in terms of exponential function. So x of t is equal to d by dt of t into e to the power minus 2t into sine t. I can represent it as e to the power jt minus e to the power minus jt divided by 2j into u of t. So we can split it up. So 1 by 2j, I will take it outside. Differentiation of 1 by 2j is constant, so 1 by 2j with the d by dt of t into e to the power minus 2t into e to the power jt into u of t. So second term is minus t into e to the power minus 2t into e to the power minus jt into u of t. So this is what the term which we can take it. So we have, and suppose I take this looking into this particular term, e to the power minus at into u of t. So this is already, we know earlier also we discussed about this, e to the power minus at into u of t. Its Fourier transform should be 1 by a plus j omega. So where a is here is 2, so 1 by 2 plus j omega is going to be get. So this is what I just written how earlier we can take on the equation. So only for this term, these two term, e to the power minus 2t into u of t, its Fourier transform I can write it as 1 by 2 plus j omega t. So here if I include now the t along with this, so if I include t for this, so what is required? Frequency differentiation property. So from the frequency differentiation property, it says the minus jt. So let me take that. The definition for frequency differentiation property is minus jt into x of t. Its Fourier transform should be d by d omega of x of j omega. So frequency differentiation, its input or the inverse Fourier transform should be minus jt into x of t. So I'll consider with respect to the given equation, this e to the power minus 2t into u of t as x of t, and minus jt, I will not take minus j here, I will take minus j to the other side. Only t is written because this is t into e to the power minus 2t into u of t. I will just take it. Later I will include this term e to the power jt also, but t into e to the power minus 2t into u of t. If I have minus j here, no issues, but I'll take minus j to the other side, minus 1 by j. That means if I multiply numerator and denominator by j is j divided by minus j square. So j square is minus 1, minus plus 1. So j is remaining in the numerator. So j into d by d omega of x of omega, x of t I considered only e to the power minus at into u of t. So its corresponding x of j omega is 1 by 2 plus j omega. So differentiation of 1 by 2 plus j omega will be minus j divided by 2 plus j omega whole square. Minus j into plus j will be j minus j square is a plus 1. So 1 by 2 plus j omega whole square is retained. So over here, so I got it as 1 by 2 plus j omega whole square. So next I just need to be introduced is e to the power jt. So if I introduced e to the power jt, so I just can go the frequency shift property. So e to the power j beta t into x of t, Fourier transform will be e to x of j of omega minus beta we can get. So suppose I just introduce e to the power j beta t with x of t. So x of t now here is t into e to the power minus 2t into u of t will be x of t. So beta is equal to 1. So what is going to be happen? So the x of j omega will be 1 by 2 plus j omega whole square. So that need to be changed by x of j of omega minus beta. Beta is 1 here. So 1 divided by wherever omega, I just need to be changed as omega minus 1. So 1 by 2 plus j omega minus 1, the whole term will be a square. So this is how I just taken the Fourier transform term with the help of frequency shift. So similarly for e to the power minus jt if I have, so because the given term earlier we have this particular term which we take an x of t after simplification, I got these two terms. So if I introduce 1 by 2j, it will be a simplified term of t into e to the power minus 2t into sine t of u of t. So where 1 by 2j is missing, but t into e to the power jt into e to the power minus 2t into u of t minus t into e to the power minus jt into e to the power minus 2t into u of t, its Fourier transform should be 1 divided by 2 plus j into omega minus 1 whole square minus 1 by 2 plus j within the bracket omega plus 1 bracket closed whole square term will be retained. So if I take 1 by 2j here, its Fourier transform should be, if I take it the using the help of time differentiation property, what we can say d by dt of the x of t term. So d by dt of x of t term is j omega into x of j omega. So d by dt of x of t means I should have 1 by 2j here. So 1 by 2j here. So 1 by 2j, it's a differentiation will be outside as it is 1 by 2j, but j omega into 1 by 2j with x of j omega term for the x of t. So this is x of t. I just this is after simplification I can get it as the term. This is earlier the previous slide I just mentioned about this term, how we can simplify it as sine t into e to the power jt minus e to the power minus jt divided by 2j. That's what I consider. So 1 by 2j is outside, so 1 by 2j I just taken. So j omega 1 by 2j with the its a term Fourier transform is I written as it is. So j cancels. What is remaining is for the given x of t, its Fourier transform x of j omega, the x of t, its Fourier transform is x of j omega will be omega by 2. Within the bracket I have 1 by 2 plus j omega minus 1 whole square minus 1 by the within the bracket 2 plus j within the bracket of omega plus 1 bracket closed twice whole square term will be remaining. So this is what how we got it, the Fourier transform of x of t with the help of three different properties as time differentiation, frequency shift. In the earlier slide we mentioned about frequency differentiation properties are used. So this is how we found the answer and the Fourier transform for a given x of t term. Moving on to the next problem, the problem statement is simple. Find the Fourier transform of given x of t is 2 by t square plus 1. So here I will use the duality property to solve this. So as per the duality properties, for a given x of t, its Fourier transform x of j omega, then x of capital X of jt, its Fourier transform should be 2 pi small x of minus omega. So duality term conditions are used here. So we know that e to the power minus a within the bracket of t, within the magnitude of t. So its Fourier transform should be 2a divided by a square plus omega square. So term will be 2a divided by omega a square plus omega square. And the x of t, suppose I taken, so its x of t I taken, x of t I'll consider as e to the power minus at, where a is, I'll take it as 1. So e to the power minus with magnitude of t, its Fourier transform will be x of j omega should be a is equal to 1 here, so 2 by 1 plus omega square. So using the duality properties or conditions, capital X of jt, that is nothing but I just need to be considered this as capital X of j as 2 by t square plus 1. Its Fourier transform should be 2 pi x of minus omega, where x of minus omega should be in terms of e to the power minus omega should be e to the power minus omega, because we should have 2 by 1 plus omega square. This is omega square term. If I suppose I should have e to the power minus omega. So t replaced by omega, omega replaced by t. So that is what the observation which you need to take. So 2 pi with x of minus omega should be 2 pi e to the power minus of, within the magnitude we should have minus omega. So e to the power minus of, under the magnitude we should omega replaced by minus omega. So 2 pi minus of magnitude of omega, so will be retained. So x of j t will be 2 by t square plus 1. It's for a transform directly I can get it as 2 pi into e to the power minus of magnitude of omega. So this is how I just find the Fourier transform of a given x of t. So any problem, any statement, if it is given, solving through the help of different properties, you just need to understand which property is better to simplify the given any x of t. So from that I can get x of j omega. So vice versa also we can do it. So with the help of some different properties or analogies which we need to use. Keep learning, keep looking for different problems, different varieties, or same the kind of problems also you can take it out and you can try to solve it. Look into the different authors, textbook and all. Thank you for listening.